we can start now also because I have to advance something. We have to finish at 1 sharp. So we have to be really on time. Next paper.
Yes, it's nice to be here again in person or whatever, in these nice buildings, but not only in these nice buildings, but also to meet people is something which is really nice. And so my title was The Internet of Things and the Governance of Big Data and Artificial Intelligence. And so when I started to begin to write this paper, I was not expecting that artificial intelligence plays such a role in this context. And I had to learn a lot on this topic, because my first point is that there is a complementary role of big data and artificial intelligence in smart network industries. The collection and processing of large data sets, they call it big data, does not come in isolation, but is evolving based on a combination of data collection innovations due to rapidly decreasing sometimes camera-based sensor technologies, strongly increasing computer processing and storage capacities, as well as innovations in communication technologies. In meantime, big data cloud computing is gaining increasing relevance for local, regional, and cross-country data traffic driven by the high bandwidth capacities of 5G networks. 5G networks played a bigger role in the nice DGX project, where we saw the title of the cover of the book. Cloud computing is gaining a pivotal function in the entrepreneurial design of data value chains for real-time adaptive sensor-based applications in many use cases of the Internet of Things. Classes of use cases requiring a tactile internet, for example, driverless network vehicles, smart manufacturing, augmented and virtual reality, are concomitant with massive and high velocity data sets challenging the traditional approaches, for example, statistical analysis or optimization theories, to derive the relevant decision based on the insights from this data. This is the very reason why artificial intelligence relying on algorithm-based pattern recognition becomes so relevant within the network industries of the future. Of course, then I started to look what are the EU regulations of big data and artificial intelligence, which are in process, either just finished or soon will be finished. We have on one hand the important precondition for the development of AI is the access to big data. The focus is therefore on two topical complementary waves of reform initiatives: the EU data strategy on one hand, and the AI for Europe strategy on the other hand. I have listed it in the back of these documents. The nature and design of AI systems is concomitant with the creation of European data pools, enabling big data analytics and machine learning, taking into account data protection legislation and competition law for the emergence of data-driven ecosystems. The important role of AI systems based on big data increases the role of data sharing and open data for AI applications in many areas of the economy, such as transport, agriculture, financial services, marketing and advertising, in science, in health, in criminal justice, in security, in the public sector, for applications using augmented and virtual reality, etc. The nice OECD study from 2019, where we have a good survey on these cases. So when thinking about RE and combine that, one has to think about also about big data, and one has to think about the search for innovative algorithms. That went back to my studies in mathematics a long time ago when we were thinking about the simplex algorithms and all these easy algorithms at that time, but the history of RE dates back to the 1950s. Turing, 1950, raising the question whether machines can think, develop the so-called Turing test, whether a suspicious human could have a conversation with a hidden computer and would be convinced it would be a human. In the same year, Shannon proposed the creation of a computer that could learn to play chess, pointing out its possible relevance for many other areas at that time already, such as machines for translating languages or for routing of telephone calls. And the Dartmouth Summer Research Project workshop in summer 1956 is nowadays at least considered as the birthplace of the research on RE. Strong increases in computation power due to transistor innovations, as it is called the winter of RE, the long time of the winter of RE, not much happened at that time because strong increases in computation power to the transistor innovations, network computing based on broadband capacities, and the associated computational and storage capacity during the 80s and 90s strongly increased the potentials for RE. These developments became even more disruptive due to the 5G innovations of quality of service differentiated broadband capacities, together with the big data-driven Internet of Things. Also, RE has the character of an umbrella term with different meanings. You can find different definitions what RE could mean. But looking back, its basic principle is the interaction of big data and algorithms in the search for automated decision-making for a well-defined set of objectives. The operational logic of data-trained algorithms is depending on the sensor-based data inputs. A set of actuator decisions is chosen. You want decisions automated, you frame the data inputs according to the requirements, and then let the algorithm work. So you need a good algorithm for that. Basic ingredients for definitions of RE are sensor-based data collection, reasoning or information processing by algorithm, and concomitant proposed action in the search for human-centered values and fairness, transparency and self-explanatory, robustness, security and safety, and accountability. You get new dimensions of regulations, not only privacy, but also more general ethical context when you have this RE in the context. And high volumes of raw data are typically available in many areas of IoT applications. They call it then the raw data fallacy. You have a lot of data, sometimes too much. When you have a plane flying through the air, you have too much data. You do not need all this data, but you need the relevant data. And the real challenge arises to transform high volumes of data under the requirements of real-time processing into decision-relevant information by means of algorithm-based big data analytics. Algorithms that learn and self-evolve warrant particular attention because these algorithms are no longer programmed by human beings, but increasingly learn self-evolved and adaptive. The meaning of self-learning mechanisms is twofold. RE self-learning may take place during the training, But there is also the possibility that AI machines continue learning after they are deployed. In contrast to well-established static algorithms in optimization theory, dynamic deep learning algorithms based on so-called neural networks, nothing to do with the real human brain, gain relevance for complex big data real-time applications. Nice survey by Emmett Stripe et al. The ongoing challenge for the public acceptance of AI systems is to make AI explainable and interpretable. That is one of the hardcore problems in this context. Next is the governance of AI-powered big data virtual networks. That is my real contribution in this paper, to relate that to the concept of what to do it in the physical world with all this data processing. And IoT is characterized by the complementary role of physical networks and virtual networks. To fulfill the requirements of IoT applications, for example, network vehicle applications, shared mobility service, microgrids, etc., smart manufacturing, etc., it is important that the virtual network providers have the entrepreneurial decision competencies to design the big data value chains according to the requirements of the IoT applications, combining quality of service differentiated bandwidth capacities with the different complementary dimensions of virtual networks, such as sensor networks, geopositioning services, and the division of labor between center cloud and edge cloud. I, based on this concept, years ago developed and extend that for the big data case and for the AI-powered big data case. The focus is on the requirements of 5G and concomitant 5G-based big data virtual networks, also in enabling the strong quality of service requirements of bandwidth capacities of the tactile internet. Heterogeneity of AI algorithms and machine learning is depending on the big data value chains of big data virtual networks. To analyze the potentials of AI in network industries, the analytical concept of AI-powered big data virtual networks is introduced. Also, several actors may be involved, such as broadband traffic service providers, cloud service providers, geopositioning service providers, or sensor network service providers. The final responsibility for bundling these different service components lies in the hand of the AI-powered big data virtual network provider. Platform operators responsible for the performance guarantees on the physical side of IoT applications may be horizontally integrated with such virtual network providers, and may or may not. The entrepreneurial task of the big data virtual network provider is to decide over the specificities of the AI system in combination with the relevant data value chains implemented according to the requirements of the physical IoT applications. In addition to the required data privacy and security regulations, the elaboration of new liability rules for AI interacting with traditional technologies is becoming relevant, considering AI-specific ethical and transparency applications. Ethical and transparency applications is a big topic. Now, case. I could choose a lot of different cases, but I was thinking about, I would like to think on the heterogeneity of AI. This is not to say that every big data application needs the same deepness of AI inputs. Depends on the kind of applications. That means we have heterogeneous big data virtual network depending on the heterogeneous physical applications, and that also means that AI depends what kind of AI should be applied or whether AI altogether should be applied. Depends on the cases, and I have chosen the road transportation case because there I find heterogeneity, real nice heterogeneity, which I would like to demonstrate. In recent years, big data in transport gains particular relevance with the large potentials of reporting mobility data. There is an ITF study from this year, 2022, very nice study, big study on big data in transport, and the requirements for our systems very strong. Intelligent traffic information systems, such as real-time distribution of information, are real-time without latency guarantees, and no requirements for camera-based sensors. There's no real requirements for AI in this context. Then AI in proactive road infrastructure safety management requires the sensing and sharing of safety relevant data on the entire road networks. It's a nice ITF 2021 study. I could not do all this empirical research myself, I can tell you. That is a nice study. And the focus is on accurate risk prediction and guidance for proactive road network safety management. Save life, né? When you have proactive safety management, not only reactive, but proactive. Data often remain in silos instead of being shared. A barrier for AI implementation is the fear of litigation for disclosure of identified personal information, pointing to the necessities of problem solution, adequate aggregation of data. An adequate aggregation of data is very important to overcome the barriers to the fear of that the privacy is disturbed. Automobile industry produces high volumes of floating car data, including indicators of traffic volume, speed, and data from active safety systems. Recommendation is to enable market platforms for heterogeneous data from vehicles and smartphone apps. Start with risk prediction models based on aggregated instead of real-time data. You need not always maximize the quality of the data. Sometimes it is enough to have aggregate data, and that is what this study recommends. I learned that from that study, and I was convinced from this conclusion, which are not critical for private data protection, because then you can go further. You have not this barrier of private data protection. It's recommended from the study. I'm convinced that that is good, resulting in less complex AI algorithms compared to the big data processing of real-time data sets. Last slide is coming. Big data and AI in road transportation too means we have a very important case in network fully automated vehicles. There is a process to go in this direction, takes time, of course. In any case, when it should continue, it needs guarantees for ultra low latencies, ultra high requirements for sharing of sensor data, together with edge cloud local processing of data. Otherwise, you can forget it. You need this for this platform. You need the interaction of the different video data from the different vehicles, and the platform operator needs to combine this in real time, and that is a very much a challenge. And it's an important role of sharing real-time data among different developing firms gathered in the course of the trials to train AI algorithms has been pointed out. Also, you need to train the algorithm. And for that, you had also a kind of cooperative. You would want to share the data of the different producers of cars. And there is no reason why that should not be possible. But that is only one aspect. The other is you have also the role of large-scale deep learning, which is based on massive scale data set collected from the instrumental vehicle fleet. The very nice MIT study, which I have here cited, also this study I could not do. I mean, there was a team of eight researchers for 2 years, many working years. But what I have learned is that it is possible to apply deep learning in this context and to find out that deep learning with massive data scale set need not be something where one must be so afraid for. It is only as an important kind of algorithm, which is also related to quantum computer, which is not, I did not on the slide. So that is what I would say is a heterogeneity of AI in the systems. I'm convinced that AI will become very important in the future network industries, but I also see the challenge, and we are only thinking about AI, which is in the, which is as I'm completely in line with what the EU documents are, also the new AI regulations, that you have to be careful what to allow and what not to allow. But that are big challenges, which are big challenges, but which can be solved. That is at least my opinion in this context. Thank you.
First of all, of course, thank you for the opportunity to read your really interesting paper. I was really happy to read this paper. I will try first to summarize briefly the main issues that you covered with your paper. The paper analyzes the role and potential of artificial intelligence. It also deals with IoT, big data in network industries. And the conceptual focus of the paper is on AI-powered big data virtual networks. There are three main topics that you addresses in the paper: the EU regulation of big data and artificial intelligence. Then you try to systematize the two reforms. The first one is EU data strategy, and the second one is the AI for Europe strategy. Then you dealt with the concept of the AI-powered big data virtual network, defining artificial intelligence, choosing a definition of that, then interacting artificial intelligence and big data, and artificial intelligence and algorithms are, of course, important and particularly necessary to deal with big data. And then you choose to focus on a specific case, that is big data virtual network for road transportation. In the specific, you choose to deal with the road infrastructure, safety management, and autonomous driving. Then the first contribution is a systematization of the reforms related to the access to big data and artificial intelligence. And the main aim of the paper is to discuss the evolution of the incentives to data portability and data sharing that could really favor the changes brought by the upcoming AI-powered big data virtual networks. Of course, I found your paper really interesting. The topic treated is absolutely actual and interesting, and there are many strengths of the paper. The main strengths relates to the deep discussion and description of the regulatory framework and the two waves of reforms promoted by the EU. And another interesting feature of the paper is the discussion of the relevance to have an explainable and interpretable AI. That is a topic that you covered a lot and where you focused a lot. And when possible, with a sort of human supervision, avoiding as much as possible the black box issue, particularly related to the storage and usage of data. In addition, it was really relevant and important by my point of view, the final focus, the choice of the final focus on road transportation, because it helps to deepen the discussion, which otherwise remained a little bit abstract in your previous part of the paper. Then some comments and some suggestions to improve your paper. I had some general comments. Of course, it's important the clear relevance of the topic covered and many positive elements and discussion. However, the paper will benefit from the following clarification. First of all, you didn't touch this point in the presentation, but throughout your paper, there's a claim, a sort of strong claim related to the definition of 5G as a GPT. I agree, and with our group, we still worked on the topic. So I agree that 5G could emerge with as a general purpose technology. However, it's a bit strong to say that it's already and is a general purpose technology. Also because this is still debated in the literature. Of course, I know that this is beyond the scope of your paper. However, if you use this claim, if you add this claim, you have to discuss it a little bit more and add some more citation. I know that you already worked on that, so you can add your citation, your publications, the ones of our group, of course. And I think that this will improve the fluency of the paper. Then the issue related to data protection, storage, and privacy are central for this theme. You touch this several times throughout your paper, but without a specific deep discussion of the relevance of data usage, portability, and sharing. There is, of course, the reference to GDPR and to the ethics in data usage, but it would be interesting to discuss it also among the incentives and problems related to data portability and data sharing. Then some short suggestion related to the focus on road transportation and on the conclusions regarding safety management. To me, of course, during your presentation now, it seems a little bit clearer to me, this point, but reading the paper, it was not completely clear to me if you suggested to avoid the usage of real-time data in favor of aggregated data, losing some accuracy and allowing the use of less complex algorithms to fasten the process and implementation of the AI, or if suggested exactly the opposite. During the presentation, I understood that you are for the usage of aggregate data instead than the use of instead of the opposite. However, in the paper is not so clear for me. Try to be clear in that point. Then related to the concluding section, it is clearly still work in progress. I saw that you also didn't present it here now, the real concluding section. So this concluding section resumes the topics covered by the paper with few discussion. I would suggest to add some discussion, add some suggestion regarding the incentives and the regulation changes that are needed to favor the sharing of data and their protection. So to be more, to suggest something more clearly in the concluded section, but of course it's a work in progress. So I know that it's, and then to final minor point, to final remarks. In some part of the papers, there are long lists and bullet points, particularly paragraph 2, paragraph 2.2, where you recall the regulatory framework. I would suggest to systematize it into tables that may become more clear and more easy to read for the readers. And then a final small remark, I will add earlier in the paper a definition and a description that is central, absolutely central in your paper, that is related to the AI-powered big data virtual network concept, that is not only the mere sum of the components, as you stated during the second part of the paper. I would suggest you to add it also at the beginning, so for the reader it's clear. Yeah, it's clear to follow. It's easier to follow the whole discussion. And that's all. Thank you. Thank you once again. It was really nice to read your paper and to listen to your presentation.